Welcome to the Real Python Podcast. This is episode 106. Do you know the difference between creating a class instance and initializing it? Would you like an interactive tour of the Python Pillow library? This week on the show, Christopher Trudeau is here, and he's brought another batch of PyCoder's weekly articles and projects. We talk about a recent Real Python tutorial titled Image Processing with the Python Pillow library. It walks you through manipulating, filtering, and creating images from scratch. Christopher shares an article about Python class constructors, exploring the two-step instance creation and initialization process. We also have a couple of discussions this week. The first is about contributing to open source projects, and the second is about searching large code bases before adding features. We cover several other articles and projects from the Python community, including the counterintuitive rise of Python in scientific computing, preparing for interview questions, bringing the hell of pointers to Python, and a fast and powerful graphical user interface toolkit for Python with minimal dependencies. This episode is brought to you by FusionAuth. FusionAuth is an authentication and authorization platform built for devs by devs. Try FusionAuth for free at fusionauth.io/download. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there. How are you?
Good. I'm excited. We're going to bypass doing some news this week and dig right into some topics and kind of double up on the discussion thing. We got some good stuff to discuss. I'll be starting it off. Mine is a real Python one to start with. It's image processing with the Python Pillow library, which I've mentioned Pillow a handful of times on the show. I had Mike Driscoll on the show before to talk about a book that he did on the Pillow library. This is an article by Stephen Gruppetta. I really had fun going through the entire article. I think people already know that I like kind of messing with graphics and playing around. And I had already kind of used a little bit of the Pillow library, but probably my favorite thing about this tutorial is it's done by exploring the library using it in an interactive REPL. And you could use whatever interactive REPL you want. It could be like a Jupyter notebook or IPython or what have you. I just end up going, typing Python and playing with it and importing. But you really get this kind of feel of play, of messing around with it. And I really think that's a nice way to kind of approach this stuff. And I think it encourages people to explore what you can kind of do with it and sort of like, okay, well, what autocompletes as I kind of mess with this? It gives you a whole set of images to kind of play with. So there's some nice images to kind of work with. You initially just start, all right, make an image, bring it in, open up the file, and then you start playing around with very common things that you might want to build like a command line application to do. Things like changing the format that it's in, changing the size, changing the mode, mode being the sort of color space that it's in. Is it in CMYK, which is like for print, or RGB, or just like a pure luminance, which is just grayscale? It has all those kind of easy sort of functionality ready to go for that. It takes you through cropping and scaling, and then, the all vital .save method. From there, it really digs into a whole subset of what can you do with photos in a tool like this. And he references a book several times. It's called Digital Image Processing by Gonzalez and Woods. And so he references it a couple times. So I'm guessing he got a lot of his ideas kind of coming from there. And it seems like a really good resource also if you're interested in this. But at that point, you're working on really processing the image, and talks about convolution kernels and these filters that kind of work inside that. It has a lot of built-in stuff. It has, blurs, box blurs, Gaussian blurs. shows you techniques of sharpening and smoothing and some of the math really kind of behind all of that and how that's kind of working, which I think is really kind of a neat thing to explore. Sharpening and smoothing, edge detection, edge enhancement, embossing, things that you might have played with in the filter section of something like Photoshop or even a simpler tool for doing filtering. And then it gets into, we talked a little bit about the mode and the idea of an image being made up of channels, the red, green, blue channels, RGB, and how you can segment an image into that and how each one of those will have its own sort of L or luminance in there. And from that, it kind of is leading into this idea of, well, maybe we could look at building something to superimpose an image on another by kind of making a mask. So you look at the different channels and which one has the most contrast in it, and then you're defining things. And then he gets in this really cool thing where he's like setting thresholds and then using a tool of erosion and dilation within the simple image to take uses a really nice simple image of a white circle on a black background. The image is sort of split in half. The other half is a white background with a black dot on it. And so as you do something of like eroding it, you can see the changes on both of those sides or dilating it and how you can kind of push the threshold one way or the other. And in the end result, again, hard to explain over a podcast, you build this image where it's a picture of a cat and you want to sort of cut the cat out of the background and have it by itself by building this filter and then superimpose it using this paste tool that's part of the library. And it turned out really cool. I think it's a neat technique of working through that. And then one of the other tools is creating a watermark. The very end is playing with some NumPy stuff where you're using methods to do things like those little puzzles they have in the newspaper sometimes, spot the differences between two images. What's changed, there's like 5 things that have changed or whatever. And he's using NumPy to kind of do that from one image to another to kind of literally extract those things that are different from one or the other, which is neat, kind of using some of the methods and mathematical tools that are built into NumPy to do that. And then he uses NumPy to actually create raw images and then do some kind of cool basic animation at the very end. I just really dug it. I had fun going through it. And again, it was very playful because it was all in the REPL kind of playing around and messing with. I could see this being a fun experiment to do with kids in the sense that they can kind of mess with this and see results right away. Again, I always kind of like those things where you're getting kind of instantaneous results from it. So yeah, I dug it a lot.
Cool. Pillow is one of those libraries that I use a lot and very little of it.
What are your tools you use?
No, I don't mean like from switching to other tools. I mean, it's one of those things that it's like this really deep library and I almost only ever use the surface level stuff.
So you're like resizing and cropping and things?
Yeah. So particularly when you're doing anything on the web where people are uploading images, you almost always need to create some sort of thumbnail, that kind of stuff.
Yeah.
And there's plugins in Django that help you do this and, they're hitting Pillow underneath. So it's one of those places where it's like, I'm familiar with it. I kind of know what it does. And I use, whenever I use it, it's like 3 lines of code and then never do anything else with it.
Yeah. The thing that Mike's book, he was trying to sort of head toward at the end is to involve a GUI library and kind of make a rudimentary photo editor. And I have existing tools that, go way beyond the scope of something like this. So I would think of some of these more coarse, very specific things like you're talking about, generating thumbnails, changing the format that it's in, maybe reducing its size or whatever. Those are probably common things that you could kind of run through it. But I could see a handful of these other ones, like the ability to kind of do sort of basic enhancements to something, or again, create these sort of filtered effects that you could kind of apply in a regular fashion, in a programmatic fashion, or batch processing fashion.
Sort of connected to that, you mentioned the whole background removal piece. There is a project that came across that we'll probably be including in PyCoders in the next issue, called RemBG, and it is built on top of Pillow, and it's a tool for removing an image's background. So essentially, they've taken the code that does that thing that you talk about of bringing the kitten out.
Yeah.
And you put an image in, and it spits the foreground out. Pillow, again, it's got the the basic pieces are definitely there. It's a deep, deep library, but it's also one of the things that there's all sorts of tools out there that folks have built on top of as well. I suspect it's one of the more commonly, what am I trying to say?
Imported or used libraries.
Yeah, I think it's one of the more commonly based tools that a lot of other tools are built on top of. It's a foundational library.
Yeah, I think so too. Mike's book, just to reference it, is Pillow: Image Processing with Python. And we talked about it quite a bit while he was still sort of finishing the book up. And one of the things I neglected to mention is we talked about the idea of like extracting metadata from that, which I think actually maybe even cleansing that would be kind of a nice kind of batch processing tool. Like as people submit images, a lot of people don't realize that, like your phone and other camera tools like have not only information about like the lens that's being used on it and the resolution and date and so forth, but also location information that could be compromising, sort of public information that you don't want to share. So that might be a nice kind of thing you could do with it. And Pillow has that ability too. So lots of stuff in that library. It's very powerful. So what's your first one?
So everybody knows, right? Python's slow. We all know it. Everyone talks about it. It's got to be a fact. So the article that I'm talking about first here is by 3 researchers at Surfax, which is a European scientific research institute. And they posed the question, since everybody knows Python is slow, why is everyone in science using it? The article is called The Counterintuitive Rise of Python in Scientific Computing. They start with a comparison with what used to be the dominant scientific programming language, Fortran. And speed-wise, spoiler alert, Fortran wins, hands down. There's no question.
Yeah.
It's fast. It's a compiled language, and Python's an interpreted one. So this is sort of a no-brainer. The interesting point, though, is that nobody in the scientific community codes in pure Python. So it's a flawed comparison. You're almost always using something like NumPy or scikit-learn or pandas or something like that. And as the scientific stuff's all number crunching, NumPy is one of the more common ones, and it has a huge speed difference. So in the tests they ran, they were seeing between a 100 to 1,000 times performance improvement between doing it straight in Python versus doing it in NumPy. And they've got a nice little graph that shows Python and NumPy and Fortran and some others. And Fortran still beats NumPy, but it's a lot closer than Fortran and Python. Interestingly, Python, which we talked about a couple episodes back, beat out Fortran by a tiny amount as well. So part of their argument was you can even just tune this a little more and you can even beat Fortran. And the article could stop there, right? The argument being NumPy gets you close enough performance-wise that the cost of that performance difference might be worth paying in order to code in a more modern language. But the article doesn't stop there. It takes it one step further. So they tell this little story about the adaptation of an internal tool that does a high level of computation in a 3D point cloud. And in the story, their programmer, Bob, whose name is in quotations, I suspect to protect the innocent, ports this program from Fortran to Python and NumPy. What Bob discovers after getting things into NumPy is that there are a whole bunch of libraries out there that can do data representation and management that aren't there in Fortran. By using a better algorithm that Bob would never have coded himself, he was able to take advantage of some computational optimizations, and the end result, that thing that took 6.5 hours to crunch numbers in Fortran, ran in 4 minutes.
Wow.
And this is what I like to call the unit test argument. If you've got good unit tests, you're more likely to feel safe to experiment. So the tests will tell you if you broke your codes. You're willing to play around a little more, right? So the same thing kind of goes here. Bob, you can hear the quotations in my voice,
Yeah.
It would never have attempted to use this KD tree representation in Fortran because he would have had to have coded it himself. And up front, he wouldn't have known whether or not there would have been a return on investment in that effort. But because it can be plugged into NumPy easily, almost for free, there's this value in going, okay, let's try it. And it turns out that there was a huge gain. So this is where library compatibility and language flexibility can vastly outweigh a small performance difference in an algorithm. Of course, any article that says it is okay that your language of choice is slow is going to feed my confirmation bias, but my confirmation bias makes me happy. So I like that. It was an interesting article.
Yeah, that kind of dovetails into my last conversation with Pablo Galindo Salgado. he had been working in scientific, computing and doing lots of work. And the reason that they were still using Fortran at the time was just that's what they had always used. But he had said himself that they were definitely moving in the direction that we're just talking about, this article covers. And I can think of a handful of, reasons. One, just the development time of creating things, the pleasure of writing in it compared to writing in Fortran. Sorry. Um, if the rest of the community is there also, doesn't that mean that there's way more tools and development and support and so forth kind of happening there, as opposed to in a language that is maybe not as popular? I'm not trying to have a popularity contest. I'm trying to think of you still trying to get things done and find the things that you need and hopefully find solutions, which is awesome. So that's a cool story. I like this type of article.
Yeah, and honestly, we live in this day and age. There are some exceptions where you have to be very careful about your performance, but oftentimes the answer can just be, throw another server at it. And that's something that, early on in my coding career 30 years ago, I wouldn't have been able to do. But now, it costs almost nothing to spin up another server. And the cost of developing things is so expensive that if the algorithm runs a little more slowly and it here's $5, you can go have another server for a week versus the $100 an hour your programmer might be making, right? So this is the trade-off. It isn't always just, hey, your language is slower. It's also the environment it runs in. It's the tools that are associated with it. It's the efficiency of the programmers themselves that makes the difference, right? And that's really where a lot of your costs are nowadays. So it can make a startling difference in the overall project view versus just measuring how fast was that little piece of code.
Yeah, and I think that you're going to find more and more with the popularity of Python, more and more people able to kind of get into it. I mean, I'm excited by the growth and popularity of it, but it's nice to see that when you kind of go beyond that base assumption that it's like, well, you got to look at the whole ecosystem. So
completely.
Yeah. So my next one is kind of a fun one. Like it took me down a real rabbit hole. When I saw this come up on PyCoders, I almost was immediately like, oh, this is going to be good. And it's 20 Python interview questions to challenge your knowledge. And I know interview sort of tutorials and articles are kind of a popular thing, getting people prepared for this. But as I read through this, I was like, oh, we did an episode about that. We did an episode about this. We've talked about this. And so it felt good to see, that, okay, I'm on the right track as far as some of the stuff that I'm trying to cover in the show and make people, aware of in this community. So the article is by Ahmed Bezbez, and it's on Medium as another towards data science article. Like right away, the first one is the difference between a list and a tuple. So that's like out of the last time we talked.
I was about to say, sounds vaguely familiar. Yes.
Yeah, exactly. What are generators? I had a whole conversation about that. What are decorators? That was the first episode. Args and quargs and how to use them. So yeah, these are, again, common things that you should be comfortable with. And these are sort of just bite-sized little, bullet lists of and some code examples kind of showing you what's going on in them. So I won't hit all 20 of them. What I do want to share is kind of the resources I kind of found beyond that. Just another one real quick is difference between a module, a package, and a library. Spent a lot of time on that. You've done tutorials on multi-processing versus multi-threading and kind of understanding that difference there. So yeah, lots of stuff. And then a common one that is a little different in Python is this idea of pass by reference or by value when you're passing things into a function. And so maybe we'll talk a little bit more about that. And then I guess, did we talk about assert last week? Not using assert? Or maybe it's just in my brain because you had a testing course that's coming along soon in talking about it.
No, there was a real Python article where we were talking about it. I think it was about 3 or 4 episodes back.
Yeah. Okay. So anyway, just the idea of being careful with that. So what it links to at the end of this article is another article, which I think was really inspiring this person in a way, but it's the top 50 Python interview questions for data science. And this one's by Analytics. that's with an X, Labs, Analytics Labs, written by Neha Seth. And so this goes a little further, but it has a, like a Python section, Python interview questions for data science. Both of them, I think, mention PEP 8, name some mutable and immutable objects, compound data types, and data structures. Anyway, this big list, regular expressions, namespaces, and then it goes into pandas and visualization. So kind of getting the data science section and so forth. And I think they're both good resources because they're kind of giving you quick answers to a lot of things and maybe helping you kind of spur your studies if you're kind of a little rusty on something like this, if you were going to be asked about these concepts. But what's great is I feel pretty comfortable by a lot of these concepts, just kind of looking through them and going through them by the podcast. And one of the answers that was in there was this idea of pass by reference or by value, and how Python really is doing something completely different. And it took me to something I'd never found in the documentation from python.org. So docs.python.org. There is a programming FAQ, and it has answers to lots of questions. And one of the things is, how do I write a function with output parameters, call by reference? And the thing that's different about Python is that you need to kind of remember that arguments are passed by what's called assignment. It's creating these references to objects. There's no alias between an argument name and the caller and the callee. So there's very different than this sort of call by reference kind of functionality. And it actually is a really nice explanation that's in there. And there's a ton of these answers to these, again, frequently asked questions. Why did changing list Y also change list X? So all these kind of ideas like, okay, well, yeah, we've discussed that also, like the idea of like, okay, well, it's mutable. And, that if you've done this sort of assignment type of thing, that they're potentially pointing to the same thing. Anyway, so it's a big list. There's a general questions, a core language sections, numbers and strings, performance, sequences, tuples / lists, objects, and then modules at the end. So check it out. If you haven't seen it before, it might answer some of your questions and maybe give you a little better direct feed than going directly to Stack Overflow to look for some of these answers. Anyway, I sort of just stumbled on it through kind of a couple hops from looking at this. So I find both, all three of these resources to be kind of handy, again, to kind of just look at like, well, where's my knowledge right now? And could I have a conversation about these things that made sense to explain these topics in an interview setting? And
well, I also find these kinds of resources very useful when you're coming from another language, right?
Yeah.
So if you've got the programming background, nobody wants to do that basic tutorial that's like, this is a variable, because, you've done it before and often several times.
Right.
So really what you're looking for is language differences, right? So, okay, all right, how do they pass variables here? Oh, okay, it's a reference mechanism. I get it, right? So it helps me sort of classify the language as I'm trying to pick it up.
Yeah.
So something particularly like this article, most of these questions are sort of high level, and they're little bits and pieces from different parts of the language, different parts of the standard library. So if you can answer all 20 or use it as a checklist, it sort of gets you to a place where, okay, I've got a good overview. I think I know, the ins and outs at least of what the language looks like.
Right.
So you can sort of use it in a certain way as a learning checklist. And it's unfortunate, but you get into things like that question about, is it a module or a library or package? My answer is I don't care. Do you know what I'm talking about? Yes, great. Let's move on. But unfortunately, you can't give that answer in an interview. You're supposed to be able to answer these things. So,
right.
Yeah, pedantry notwithstanding, sometimes that'll get you past the interview.
Well, you did a course kind of looking at sort of differences between Python and JavaScript. And so, you called them lots of gotchas kind of between the differences there. Or was it JavaScript for Python developers? Was that the idea of it? I'm trying to remember.
Yeah, it was. Essentially, it went through a whole bunch of the things that if you're a Python developer, you would expect to work in a certain way in JavaScript, and don't.
Right.
And in fact, it's broader. Although the course is very much aimed at Python developers, I found when I first got into JavaScript, I was constantly banging my head against the wall because it wasn't just my expectations from Python; it's my expectation from every other coding language I've ever done. Right? It's like,
okay,
what do you mean arrays can have holes in the middle of them? And why would you do that?
Yeah, it's different.
So again, it's that concept of do you understand the high level pieces for the language, and if you're one of my favorite gotchas in Python, which is a niggly little thing, but it's about how to you do not want to have default arguments in your functions that are mutable, because you'll get surprises and people don't expect that, and that's one of those things that can create tricky bugs. So when you're learning a new language, those are little corners that you want to learn about.
Yeah, definitely.
Which, complete tangent, but there's a PEP coming up that is talking about adding a syntax difference so you could make that a choice, which may cause arguments a la walrus operators all over again. But there are some conversations going on about it.
Auth is a necessary component, but is it really a differentiator for your application? FusionAuth solves the problem of building essential user security without adding risk or distracting from your primary application. FusionAuth has all the features you need with great support and a price that won't break the bank. And you can either self-host it or get the fully managed solution hosted in any AWS region. Get started for free at fusionauth.io/download. So what's your next one?
So this is a real Python article. It's called Python Class Constructors, Control Your Object Instantiation. Once again, by the ever-fruitful Leonidas Romas, and talks about how object creation works in Python. So if you've done any object-oriented programming in Python, you've probably come across the dunder init method. Dunder, in case you haven't heard people say that before, is how Python programmers say that double underscore thing, which is an indication of a special method. So dunder init is where you typically create your object's instant variables and run any setup code. So the init is short for initialization. So this is the initialization method. What you might not know is there is another dunder method that gets called before dunder init, and that's dunder new. This method is responsible for the object's creation. So getting a new instance of an object is actually a two-step process. It gets created and then it gets initialized. So if you've ever run across somebody who, speaking of pedantry, who got cranky when you called dunder init a constructor, this is why. Technically it isn't. It's an initializer. 99% of the time, the default implementation of dunder new is good enough, so you don't typically have to override it when you write a class. One time you might want to override it is when you are trying to subclass an immutable built-in type. The example given in the article is creating a class called distance, which subclasses float. So imagine you want to store a distance and the unit of those distances that goes with it. So I'm going to have 35 miles or furlongs or angstroms or meters or what was I talking about? Right, distance. So you can just subclass the float and use the number from the float to store the distance, but you also want to add in the unit. Well, you can't add another argument to a subclass of float because float is expecting exactly one argument. So to get around this, you override the dunder new method. Your overridden method would take both the value and the units as arguments, and then it would call the supers dunder new for float and pass it just the value, and then you store the units on the object and then return the newly created object. The other example he gets into is a bit trickier. Your dunder new method has to return an object instance, but it doesn't actually have to be the class's object instance. You can use this for creating certain kinds of factory patterns. For example, if you want a random selection between dogs, cats, and snakes, he actually calls them pythons, but that's just going to get confusing. You could have a pet class, which as part of dunder new makes a random choice and returns either a dog, a cat, or a snake object. This works fine with one caveat. If the dunder new method does not return the same kind of object as the class, the dunder init doesn't get called. So this allows you to sort of create factories of different kinds of things. You can take in strings to configure factories, that kind of stuff. So it's an interesting little extra arrow in your programming quiver. So Leonidas wraps up with a couple more examples where you might want to override dunder new, one of which is implementing a singleton. One small word of caution, which I ran into when I was playing around with it, if you're still coding in the Python 2 world, this does work in Python 2, but only if you explicitly inherit from object when you declare your class. So my pet class would be the word class, then pet, parentheses, object, closing parentheses. This is what is now a very dated term called the new object declaration style, which is now the old object declaration style. And it's because Python 1 did it differently. So if you use the old style in Python 2, it won't behave this way. It'll behave in a different way. So if you're doing object-oriented programming in Python 2, you should always inherit from object explicitly. But there's this little corner case where things might not work if you're playing around with this article.
I'm going to have to dig into this much deeper because it's not something I've really seen, the constructor. I don't see .new often, or dunder new often in the examples I've seen in the past. So
it's one of those things that I think the only time I've come across it was when I was playing around with meta classes.
Okay,
it's one of those things that's kind of buried in the back of the brain. And I'm like, when I saw the article, I'm like, oh yeah, I forgot about that. That you can do that in Python. But it definitely was. If you'd asked me, how does init work, I would never have said, oh well, dunder new gets called and then dunder init gets called. It's just not part of my mental model.
Yeah. Well, cool. Yeah, that sounds like a good resource to kind of dive into it. He's always super thorough.
Yes.
Leonidas is, yeah. I think that takes us into discussion land, and we have two of them today. The first one, I guess I'll kind of just mention what it is. This is a Hacker News thread. It is, do you contribute to open source projects? Is basically the main thread. A person says, I'm looking to contribute to open source projects, but just could not find the time since coding without pay is so foreign to me. I could not just approach my employer and ask if I could help code this open source project. What is your motivation for doing such things? Thanks to all the open source maintainers. And this is by Dirty Low Profile is his name. So the original poster. And I had a bunch of ideas here. Like, one of them is I do see this trend of employers giving open time. It could be, like 20% of their time or a certain chunk of hours in a month or something like that for their employees to be able to contribute to open source. The examples I have are people I've had on the show. Brett Cannon and Anthony Shaw both have mentioned that they get that from Microsoft. Pablo, who works for Bloomberg, has a bunch of projects that he's working on, and obviously he's doing lots of things as a core developer, but also being the release manager. But I feel like a lot of large companies are also looking at this idea of, if I'm using open source, the libraries that we create internally, there is this sort of almost legal obligation that their software that they're creating based upon this other software in a lot of ways needs to be opened up. And the way I'm sort of thinking of this is, the conversation I had with the gentleman from Netflix in their tool Metaflow. And so a lot of these big organizations end up kind of using additional tools or building things that they use internally and then opening them up. But yeah, it's hard, like, depending on your employer and kind of their worldview, to be able to, if you're working 40 hours or more a week, to find the time to do it. I think you were saying to me before we started that you had a little bit of experience kind of in this world of an employer and kind of having the conversation with them about open source.
Yeah, a lot of the folks I've worked with, you get a huge range of response. You get some who are deathly afraid of the GPL because some lawyer has told them that their entire business will collapse if they get one line of GPL code anywhere in their base. And then there's others that fully understand that nowadays you almost always are built using other people's open source pieces. So the argument I usually make is, hey, we're using these 15 libraries. I need to write a library. You're going to pay me to write the library anyways. This isn't a key part of our business. Why don't we give back to the community and write a 16th library and put it out there? And there's no obligation of support. You can just sort of throw the code up there on GitHub and, use BSD licensing, and it's there. And if other people take advantage of it, great. If they don't, they don't. The other aspect of it as well is there's always that chance that, it attracts a programmer. They see it. You can put your little company name on it and say, hey, this was built using funds by so-and-so. And there's a PR aspect of this that is valuable.
Yeah, that's interesting to kind of mention that, somebody can see your project and maybe contribute to it in a way, and then they also could be a good candidate for your company in some ways. This is kind of a nice sort of fruition. I wonder sometimes, though, there are a lot of open source maintainers that, occasionally it can turn toxic, the idea of the support level that people assume that they're supposed to have. But, I guess that depends on the library and the popularity of it and so forth. But we've talked about that, kind of handling those expectations.
You mean there's jerks on the internet? This is news to me. I haven't experienced this.
Wow, great. Canada's so much nicer. Their internet is so much cleaner.
Yes, that's right. Our internet's filtered. Yeah. Our internet is not filtered. That was a joke before somebody starts. Before somebody gets all jerky about it in the comments. Yeah.
Exactly. Darn it. We could use those filters. All right. Well, one of the things I wanted to mention is that, later in the thread, some people said that contributing, quote unquote, to open source projects doesn't always have to take the form that is, pure development and taking it on as like this part-time job of, helping to lift this project up. It could be simpler things. And some of the ways that I've thought about, and I haven't done yet, I've been kind of looking at different libraries and trying to decide like how I can contribute, would be like documentation or creating tutorials for these kinds of things and offering that level of help, because that's my background. Like I am a teacher, and I like building things and explaining things in those ways. And so example files and tutorials and documentation would be probably a good entry point for me also to really learn that library and get into it. But there are other ways of contributing. And I think just sharing this stuff, like sharing, that you're using this library, that you really like it. There's also, financial contributions and GitHub sponsorship and so forth. And I feel like, in a lot of ways that this podcast I'm trying as many ways as I can to contribute to open source projects through bringing on people that maintain these libraries and giving them some exposure and kind of explaining, maybe some of the questions somebody might have, kind of trying to approach it. And so, there's lots of ways to contribute. I don't know. You have much more background in contributing, and we talked about it even last time about some of the libraries that you had been working in.
Honestly, for me, I guess there's sort of two categories in places where I contribute, and I'm using that word loosely, and you'll understand in a minute why. The most common one is just I found something that is like 99% of what I need, or I found something and it's got a bug in it. And so it's just hey, here's a PR. I need it to do this. You might find this useful. Someone else who's using the library might find it useful. Or hey, this looks like it's a bug. I'll squish it for you. And the world of GitHub and how everybody, for better or worse, is almost always there has made that far easier.
Yeah.
10, 15 years ago, it was like, even just creating a bug report. It's like, you want my email address? I don't want to give you my email address just to tell you that there's this bug here. I can get a PR together almost faster than I would have been able to create an account in the past, right? So there's aspects of that. And we were talking last time about Askimatics, the project, and I contributed to that. And he's got a text field in there, and I needed a slight behavior change for how text scrolled for a project I was working on. So I created a PR, and there's always a chance that they'll say, no, thank you.
Right.
I've had a couple PRs rejected. The one time that comes to mind, the maintainer was worried that the feature that I wanted would be too slow. So I just forked it and made the fork continue to be open source. Maybe someone else wanted to use my fork. Of course, this case wasn't Python. I won't go all tangential about the crankiness of non-Python developers. They should all just switch over. It'll make them happier people.
Yeah.
And then the second case for me, and this is where I said, the more liberal interpretation of the word contribute is when I'm writing code for myself, I almost never need it to be proprietary. Even when I'm writing something to kickstart a business, which I've done in the past, most of the time, most of the code I'm writing isn't secret sauce for the business.
Yeah.
So I've got about a dozen libraries that are in various states from dead and just sitting there to actively maintain. I'm confident that very few, if any, people are using it. It's really just for me, but it is open source, and maybe somebody will stumble across something someday and find it useful. And the other aspect of that, which is where does this time go and what is it for and all the rest of it, is this is also a bit of an active resume. People can go and see my coding style.
Right.
They can see, I've got, like I said, I've got about a dozen that I have that are mine. I've got about another dozen that I've forked to do PRs for on GitHub. And so you can see not only how I write my code, but you can see how I interact with other people's styles. And that is this thing that shouts far louder to a hiring manager. I love seeing somebody's GitHub thing on a resume because I go to there and I look at it and I'm like, okay, so what do they have? Do they have like a single project that looks like they've played around with the language once, or are they invested, or are there comments in their code? Because everyone says they do it, but when no one's watching, are you still doing it? Right. So there's
if it's just your thing.
Yeah. So there's value in this participating in this world that isn't just necessarily the will I get paid for my code?
Yeah. That kind of brings up two ideas. One is just the idea of getting paid for your code. Sure, that's fantastic. And I don't know if that's the reason that you do open source, though. Very often it is what you're talking about, of scratching your own itch. Very often maybe potentially building the resume of things that you've worked on and showing your style. It's interacting with the community. And there are ways that open source can be funded. I talked with Josh from Open Source Collective and Tidelift about some of this stuff about, the funding of open source projects. I'll talk about an open source project later. They're actually featured as one of the Open Source Collective things. And so it was interesting to kind of follow up on that and see, kind of these small areas. But hopefully some of the reasons that you're doing it is to build this community, and so I think that's one of the biggest things. And I don't know. To me, there's lots of ways that you can contribute, like you said. And I've been in organizations up to now that were very much closed off, and we weren't even allowed to really use like GitHub inside of the organization. Like sharing the code or any of that stuff was like really frowned upon, because it was like, financial institution or a law firm or what have you. And so those were kind of the jobs where I was working in a larger company, kind of creating code for them. And, we try to have our own internal repositories, but it was, just sort of a different thing. And so I'm striving this year to try to get more of my own stuff up and, out there. And hopefully I can find some projects to contribute to in that way. This week, I want to shine a spotlight on another Real Python video course. It covers the types of things a Python developer should know when starting to work with JavaScript. It's titled Python versus JavaScript for Python Developers. The course is based on an article by Bartosz Jaczynski, and in the course, Christopher Trudeau takes you through where JavaScript comes from and where it's used, how JavaScript's type system is different from Python's, how to write functions in JavaScript, and the two ways of creating objects in JavaScript, JavaScript's general language syntax, along with surprises and behaviors in JavaScript that Python programmers wouldn't expect. I think it's a worthy investment of your time to learn how to navigate the differences between two of the most popular programming languages. If you want to share your Python code and projects with others, it's highly likely you want to do that over the internet. And it would be helpful to be prepared for what you can expect when working with JavaScript. All Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. The lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. Do you want to lead off the second discussion here?
Sure. So another Hacker News thing, the question is how to search large code bases before adding a fix or a feature. So the question essentially is, I'm starting with this new code base at a new job, and I don't know where to start. What do I do? How do I do it? What does that look like? So there's a good conversation going on in here. One of the ones that is kind of my favorite answers, which is buried way down near the bottom, is a comment about tests. If there's good unit tests,
Yeah.
because the tests often run you through, oh, this thing's supposed to do this. Oh, and I can see inputs and outputs. And you're reading the code that's connected to it. And the tests are usually organized in a fashion that they're near the other pieces. So it gives you some sense of how those parts fit together. There's a whole bunch of tools in here that are like code adjacency search tools and indexing tools that I haven't seen before. So now my to-do list has grown a little bit.
Yeah, I want to mention both these threads are not Python specific.
Yes, true. Very much so. That's right. But I've got a background in this space. My grad thesis was on reverse engineering distributed software systems. And so the tools that I'm used to was all 25 years ago. So they're different, but the concepts are pretty much the same. Most compilers have a way of outputting an abstract syntax tree. So back in grad school, we were using GCC, but the discussion itself talked about things like Clang and LLVM that had the same thing. And once you've got that tree, you essentially have data about the code and you can do things like visualize it. And so one of the courses I took in school was we had to reverse engineer the Linux kernel. And we used these kinds of calling graphs and then did a whole bunch of data munging to group things together by file, by module, by OS system calls, and then produced a whole bunch of pretty charts to go along with that. And then my thesis ignored the code level and concentrated on the observation level. So hooking the distributed systems to see how they intercommunicated and what was passed back and forth between the different machines. And this was meant as like a augmentation of the other methods. So if you're really keen on this stuff, there's a whole bunch of references out there. I did a quick sort of Google to see, what's changed in the industry. I'm not going to name any names because I haven't played with any of it. But in addition to this discussion, if you Google the phrase reverse engineering, there's tons and tons of stuff out there. Some of them are even like high-end commercial grade for quality assurance of high-risk software, like flight control, manufacturing, that kind of stuff. There's all sorts of stuff. And the discussion talks about a whole bunch of tools, and then there's a lot of other pieces out there. So this is kind of a broad space, and there's plenty of parts. And if you want to get into a really deep dive, there's even stuff that still do the reverse engineering without the code base, which is deassembling, and that leads to code injection and all sorts of other gray hat fun weekend projects. So
yeah, the tips that I kind of noticed, I made like a little list of them. One, find what you can of internal documentation on this code base, which I think is good, if you can. Running it in a debugger and placing breakpoints and kind of looking at stuff, kind of similar to some of the stuff that you're saying there, and looking at existing tests and, seeing what happens as they go. If it's set up this way, look at all the imports and kind of get a base understanding of what those libraries are for and what they're doing. And then if it's strongly typed, there may be benefits that an IDE will provide for your searching. If not, they mentioned a whole bunch of these tools where they're literally doing text searching.
Yeah.
Or grep or what have you. And
most of them are grep on steroids.
Yeah. And there's like this interesting third-party tools, which I don't know if we need to dive into too much, but people can kind of look through it. One of the conversations that I want to bring up that's kind of related to that was episode 49. I talked with Dane Hillard, and the title was The Challenges of Developing into a Python Professional. And he talks about this idea of like, okay, now you're going from, this sort of basic understanding, intermediate developer, and now maybe you are in a code base. And what do you need to think about? And the ideas of refactoring and, retooling things, and if that's something that's going to happen in the code base. And his book is really good on that too. But yeah, this really brings up the thoughts of like, how do you onboard a new employee? Like being on either side of that conversation. And interesting thread. It's fun to see all the tools that are out there in the world that, some are very specific to a particular language, and then a lot of them are not, that they can kind of work across anything here.
Yes, somebody had added a list of companies and the tools they used. So it got kind of meta, right? It was like, how does Google do this? How does Facebook do this, right?
Right.
So, picking somebody like Google or Facebook that do a lot of Python, I suspect you're probably going to find tools there that might be a little more Python oriented, right? Which can help you sort of filter out as you're looking for this kind of stuff.
Yeah, they were like a codesearchguide.org and then like the story thing. Yeah, and it was like Yelp and Linux and Brave and Facebook. Yeah, it's kind of cool. Nice. All right, that takes us to projects. Do you want to go first?
Yep, if you want. So before getting into my project, I'm going to go on a bit of a tangent. And for anyone out there who's ever taken one of my courses, this is the part where you pretend to be surprised. So one of the things I do for Real Python is curate the PyCoders newsletter. This involves digging around on the internet for all things Python once or twice a week and assembling it all together, hence why you're listening to me. So we've got a lot of decent internal tools that help do this, but fundamentally the job is read a bunch of articles and try to find stuff you think other people would be interested in.
Yeah.
And rather recently, I realized as I was a couple hours into doing some curation, it was April Fool's Day. And this is a dangerous day on the internet. And so I had this sudden realization that I had to go back through everything I had just curated and make sure it had been kicking around since before April 1st.
Can we make a filter for that one?
Just to be safe. So while I'm on my tangent, I'd like to point out we do have a submissions page for PyCoders. So if you think you've written something that's newsletter worthy, please send it our way, and I'll have Mr. Bailey include a link in the show notes there so you can find that.
Yeah.
So the project that I'm talking about today brings pointers to Python. And so now maybe you'll understand the April Fool's tangent. This isn't an April Fool's joke. It is a legitimate library. It's called pointer.py. It's by somebody with the handle Zero Intensity, and the title of its GitHub page is Bringing the Hell of Pointers to Python. The library introduces a pointer class, malloc and free functions for managing memory, and a interesting little decorator that he's called decay that changes the arguments of a function into their pointer equivalents so that you don't have to munge all that when you're building out the function. He's gone as far as implementing unary operators to dereference the pointer so that you can get at the underlying object. So he's gone hardcore with it. So if you've ever done some C coding and you miss shooting yourself in the toes, this library provides all sorts of nostalgia. And Zero Intensity anticipates your main question with the answer, yeah, why not?
Right.
The underlying implementation uses libc, so he's got some OS detection code in here for things to work properly. I ran into some difficulties playing with this on my Mac, but it worked fine in Linux. It says it works in Windows. I didn't play with it there, but it was an interesting little mental exercise as to if you had asked me, could you do this? I would have said there's no way. And the fact he's done this in a few hundred lines of code is kind of interesting.
Way.
Yeah, exactly.
Cool. Yeah, so I was going through the PyCoders list and had picked out a particular project, and this kind of just relates to our conversation before. And the project was like supported 3.5 and 3.6 only, unless you went with the pro version. And I was like, this is kind of ridiculous. Like I'm not going to talk about this project. Sorry. I'm going to work with modern Python. So I sort of punted into this other area and found an awesome Python list. And I know awesome lists are kind of a fun thing that people share, like a GitHub repository just filled with links of stuff. And we talked about this when I was talking about audio, awesome lists of Python stuff for audio and so forth. But this one is awesome Python libraries and resources. So I'll link to that. And I just want to mention that it's a huge list, lots of stuff, everything from audio, build tools, caching, CMS, code analysis, data analysis, deep learning, downloaders, files, And then I stopped at GUI development and I was like, oh, let's see what the current state of GUI development is. And I have, talked about in the show about several different libraries across time. And I had seen one and I kind of piqued my interest to look at it again. It's called DearPyGui, which is a really funky name. Let me just give you the blurb. It's a simple to use but powerful Python GUI framework. DearPyGui is not a wrapper of Dear I'm GUI in the normal sense. It is a library built with Dear I'm GUI. And it's, you look at the languages for the GitHub thing, it's 84% C++. It is super fast. It basically uses your GPU to facilitate really dynamic interface kind of stuff, which I was really impressed with. And so on Mac, it's using Metal. On Linux, it's using OpenGL. If you're using a Raspberry Pi, OpenGL ES, and then DirectX 11 on Windows. I don't know. I was really impressed with it. I started just playing with it, and it had lots of kind of fun stuff right out of the box. There are some kind of fun tutorials that he shows off, like a YouTube video where he'll have like a 3D scene, like maybe you're working inside of, I don't know, like something like a game engine or Blender or some other kind of tool like that, and where you want to have like all these sort of custom tools, you can overlay this GUI interface and it'll be transparent behind all the controls that you've set up to be interacting with this other code. And so I thought of different projects that immediately spurred some different project ideas in my head. The idea of like even kind of combining it with the thing I was talking about earlier, working with Pillow. I think it might be kind of fun to have some of these palettes kind of floating above stuff as you're kind of editing it and modifying it. Anyway, so I went down a little rabbit hole with it. I think it's a fun library. I was thinking to myself, I was like, oh, is this something Mike Driscoll talked about? And I went on Twitter this morning and he's starting to play with it like literally today. And I'm like, okay, too funny. But Mike definitely is one of those guys who is always looking at the latest of GUI libraries. He's the one who introduced me to WX Python, and he's done a variety of tutorials on Real Python about this sort of stuff. But I like it. It's a neat library. I think the development, it's very active, which I think is good. He has a GitHub sponsors page, and then he, like I mentioned before, the opencollective.com, he has a support through that. So he's trying to, get a run with it. The creator, the main person behind it is Jonathan Hofstadt. And yeah, so I'll keep posted as I try to kind of play with it and build some tools with it. I just like the language, the syntax of, how you kind of work with it and, create windows and lots of tools. Like there's a real fast way to get like the demo up that shows you all the different kind of components you can kind of play with and so forth. My only minor complaint is the default font sort of interaction is super small on like Retina screens because it's kind of working at like that native point level. And so I definitely
your old man complaint. The font's too small.
Yeah, I guess. But yeah, it's just like, holy crap, I can't see this thing. And so I was quickly looking at like, okay, well, how can I make it more like native, like, like a true type font or other types of fonts that scale based on the points, not just like down at the root level. But anyway, yeah, definitely that was my big complaint. I got to break out my glasses. So, all right. Well, that was fun.
Interesting.
Covered a lot of cool stuff this week. I have a conversation about PyCon coming up soon that I'm going to bring some Real Python team members on board to talk about, along with another open source contributor next week. And other than that, I'll see you in a couple of weeks here, Chris.
Excellent.
And don't forget, do you have a side project that needs custom login and registration, multi-factor authentication, social logins, or user management? Download FusionAuth for free at fusionauth.io/download. I want to thank Christopher Trudeau for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.